As smartphones evolve to take advantage of all that 5G has to offer, the scale and complexity of the radio frequency, or RF, front end increased dramatically to keep up with the wider bandwidths and additional radio spectrum. To realise the full potential of this new wireless technology, 5G devices must be able to accommodate many more radio paths and a myriad of radio aggregation combinations. Although the industry has mostly risen to the challenge of the dizzying growth in RF complexity, another problem looms on the horizon, that of power efficiency and corresponding battery life. The smartphone is, of course, a battery-operated mobile device. Its utility is only as good as the longevity of the radios that carry its vital connections to a cellular network. With the advent of 5G, more radio resources are employed to achieve the technology's vastly improved connection speeds and user experience. But to do so, the RF front end needs a lot more power. Larger spectral bandwidth communication requires proportionally more power to transmit as well as receive wireless signals. A lot of the power expended on a 5G smartphone is during the active uplink transmission to the network. Smartphones use components called power amplifiers to increase the signal output from the modem to a level strong enough to be sent by the antenna to the fixed network towers. The amplifiers draw electrical power from the battery to do their work, but they must be carefully designed to avoid excessive power consumption. Typically, a power amplifier has a specific power profile defined by its maximum output. Radio signals, especially 4G and 5G signals, have large differences between their average and peak power levels because of the way that signals are modulated for broadcast. What this means in practical terms is that much of the energy generated by the power amplifier is often wasted and converted into heat. Most people are familiar with how mobile devices warm up during intensive use. This inefficiency can be likened to a 4-slice toaster powering up all its slots to toast just 2 slices of bread. A more efficient design can power each slot separately and only turn on the elements needed for each slice of bread. To make 5G communication viable, more practical and energy efficient, RF front-end designers use components called envelope trackers to regulate the amount of power used by the amplifiers during uplink communications. Envelope trackers add a closed-loop power amplifier control that defines the power envelope of the uplink signal. They sense the power signature of the uplink signal and apply just the right amount of power envelope signal to the amplifier to optimize power efficiency. Envelope tracking technology is a cornerstone of 5G RF front-end design. Its power management makes practical 5G operations possible on a mobile device with a finite battery capacity. Whether it's a smartphone, drone, connected sensor in the Internet of Things, or any other 5G device, envelope tracking technology extends its usefulness by making signal transmission as energy efficient as possible.